Hello guys, this is Ram and today we are going to build a diabetes prediction model. So diabetes is serious, sometimes life-threatening disease, and about 422 million people worldwide have diabetes and 1.6 million deaths are directly attributed to diabetes each year. So diabetes causes have been increasing over the past few decades rapidly. So it is necessary to predict diabetes at an early age. So I'll just show you more the sample model how we can just predict the diabetes. So this is a sample diabetes prediction model. So we just give the glucose level 137, insulin 168, body mass index 43.1, diabetes pedigree function 2.88, and age 33. So now we predict whether for the following values we can have diabetes or not. So, but fortunately, just chance of diabetes is more. So we need to consult doctor. So we'll just do some other random values. 139, insulin as 480, and body mass index 40.7. Diabetes pedigree function 0.536 and age 21. So now great. Yahoo! Yes, no worries. We don't have diabetes. So this is the sample model. So I'll just show you how to build this model. So for any data science project, we have just involved in 7 major projects. So the project name I have taken is detect. So diabetes detection using technology. So every project we have just 7 phases. First is the project planning. We have to take which team we want to do the project. So for example, in this we are taking the diabetes prediction and not data collection. So we have to collect the data from any source. For example, we can use Kaggle. I'll just show you how to do that. Just go to Google and search for kaggle.com. So here we can find any data set. So we can just type here some diabetes prediction. So I'm taking this Pima Indian database. So when we download this, we just download a zip file so that we can extract it. So no worries, I'll just do the link in the description. You can just go through it. So next we have to clean the data cleanly. That means when you have taken the data, there is a possibility of having null values. So that these null values can lead out data to the misconception and we can get wrong values. So we have just cleaned the data. And next, exploratory data analysis. So we have to take the what are the major factors contributing to our data, and we have to take those only. And next, model building. We have some several classification models like KNN, simple vector machine, naive and many things. So next, in production and documenting. So just let dive into how we can build the model. So this is the code. No worries, I will just give my GitHub link code in the description so you can access it. First, we have just import the libraries. We're importing pandas, matplot, libplot, pyplot to just plot the how the factors in the numpy and seaborn. So we have first the data collection. So as we extract the data from the Kaggle, so this is the diabetes, the CSV. So we'll just load our data into the data set. So when you just print the data here, this is all the factors: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and the outcome. So what this one outcome means having the diabetes and 0 means no diabetes. So the data, our data set shape is 768 and the other data. So we'll just count the plots. SNS dot count plot of x is equal to outcome and data set is equal to data set. So that means our 500 are the 0. That means we have, in our data set of 768, we had 500 of not having diabetes and 268 data has having the diabetes. So the value. So this is the so now correlation. Now we have just find the correlation matrix. So correlation matrix show correlation between two variables. That means 0.x and x means similar. For example, if we have taken that outcome 0, outcome 1, and age, that means for age and outcome, that means 24% age is contribute 24% in the outcome. This is the one. So similarly, a correlation between glucose and outcome is 47, but that means output depends majorly on glucose. It is. So now we have just clean the data that is any null set or null values are present. So data set dot is null and some values. But luckily, in our data set there is no null values. So now we just create a feature matrix. The feature matrix is taking all our independent columns into singular and dependent values into the other. Because for in predicting the model, we just give only the values of pregnancies, glucose, blood pressure, and will not give the outcome. So depending on these values, we have just predicted how the outcome is this. So that we are just loading all this data into the x and the dependent value into the y. So now the shape of the x is 768 or 8. So the values of y. So now explore data analysis. So now we are checking which columns are useful and which columns are not useful. So for glucose, so now we are checking whether the glucose is contributing or not. from directly we can understand from the SNS heat map only. So when you just see the SNS heat map, we can understand that glucose is contributing more, insulin is contributing more, and body mass index is contributing more. Diabetes predictive function is good, and age also contributing more. So, but we need something to do like so we're just doing some graph so that we can understand it a bit clearly. Then we take for glucose, glucose is contributing more, and similarly for insulin, insulin also contributing more to the outcome, and body mass index is also contributing more to the outcome. The diabetes pedigree function is also contributing to the outcome. So that's and next age also contributing more. So that from this we can understand that the pregnancies, blood pressure, skin thickness, and are not contributing more to the outcome. So we can just so again we are taking the excessive data set drop. That means before we have all this like in the data set we have all pregnancies from glucose and everything. So we are just removing the pregnancies, skin thickness, so that we can get the best output. So now we are just splitting the data into training set and test set. From sklearn that model selection, import train test split. So we're just importing to how to just train the set and explain so it's inbuilt function to just train the data. And here we are taking the test size is equal to 0.2. That means 0.2 means we are just using the only in 100% of data, we are using 20% of data for testing the data and 80% of data for training it. So now the extra shape is 614 cos 5 and the extra shape. So now we have to do the feature scaling. Why feature scaling? So feature scaling is to standardize the independent features present in the data in a fixed range. If feature scaling is not done, then the machine learning algorithm tends to have greater values, higher and consider smaller values as the lower values, regardless of the unit of the values. From sklearn pre-processing, we are just importing the standard scalar. So this is just creating the object for the standard scalar. Now the train value and the extra value from this standard scalar we just given the values to explain. So now we have just so data cleaning is over and the exploit data analysis is over. So now the remaining part is I'll show you. This is over, this is over, data cleaning is over, exploit data analysis is over. So now we are just to the model building. So for example, we have taken the k nearest neighbor algorithm here. From sklearn neighbors, import a k neighbor classifier. Kn is just creating the object of the k neighbors classifier. N neighbors is equal to 25, and metric is equal to minus k. N neighbors is equal to 25 because in our text string we have the 614 which is near to 25 square. Right, let me show you. Sorry, not here. Yeah, 614 which is near to 625, that is 25 square. So we have taken the so you all know, I hope you all know k nearest algorithms like this circle. So which are predicting this data, we are just the output data is just belong to it. So metric is equal to minus k. Metric means on what factor we are choosing, okay. So that is our distance. So we're just putting the data or x trend and the y trend we had update from the before a scalar loading it. Now predicting the data. K and y predict is equal to k and y predict of this. So we are not the confusion matrix. We are why the confusion matrix? Check how many correct or how many wrong. From sklearn the matrix import confusion matrix. K CM is equal to confusion matrix of y test, comma KNN underscore y underscore prediction. So now we are again finding the SNS heat map. So from the SNS heat map, we can just find like this. So that means the above heat map says from 0 to 0 or true negative. That means in our model, our model is showing from what we had above using the k nearest algorithm. 94 of the data set are showing true negative, but 16 are showing the false negative. That means even though they are even so positive showing negative, so it's not a problem. But for 13, it is the risky value because even though it's showing the positive. So print correct and 1, 0 means it's positive but showing so it changes. So we need to activate our model. So just now we'll check our accuracy, how much accuracy is present. Print correct of the sum. It is just using an inbuilt function or we can do with the two methods how to find the accuracy. So for our k nearest neighbor algorithm, we got accuracy of 81%, and in inbuilt algorithm directly from importing the accuracy score, we got as 81%. So let's check if we can improve our data like improving the accuracy. So we have just simple vector function, same the above procedure follows, but here before we have just imported the k nearest neighbor classifier, but here we have just imported a simple vector machine. Same all is same. Confusion matrix, that means 96% are correct and the 11% are wrong. So in this also accuracy is 81%. So let's go to from naive-based algorithm. So same the process is instead of KNN or simple vector machine, here we have imported the Gaussian naive-Bayes algorithm. Gaussian naive-Bayes algorithm. So the accuracy is 77.9. So comparing the naive-Bayes algorithm, we can just select a simple vector machine or KNN nearest neighbor because they're giving some more accuracy compared to naive-Bayes algorithm. So now I just send the classifier because that's all the step. We are just to the production. That's what the step is. So we just save in the classifier. Import pickle.dump and SPC open classifier classifier.pickle and WB. That means write byte and we just pickle.dump and we just save the classifier. Here we are using the simple vector machine code and open of sc.pickle and write binary. So we'll so the model is now over. Now we have just built a Flask model so that we can just store it, all our files. Just now in the app we just load all our pickle models like classifier.pkl and sc.pkl. So now I'll just show you the our Flask code. So this is our Flask model. So from here also import numpy as np, from Flask import Flask request standard template, import pickle app is equal to Flask name. So pickle.load of sc.pkl. So that's what we have to before here we have just saved the our pickle. So that's what we are just using in this. So from home it should so this is all another one. So when the homepage appears, homepage should direct to open detect.html file. And after the predicting, we have just opened the result.html file. So I'll just show you the detect.html and result.html file. So this is the detect.html file, how it is written. So now whereas I'll just provide you this code in the GitHub link down. So no need to worry. So it's done. So now how to open this Flask model here? How to open this? So it's nothing but easy. So here we have to go and open our Anaconda prompt. So I have loaded my file in the desktop, so I'll open it. So in the desktop, I have chosen my file as direct. So now we have to open the file name Python app.py. So this is how I save my file. So it will run and will just give you HTTP link so that we can run our code. So this is the link. Just copy it and we have just paste in the browser. And that's it. So I can just glucose level 137, 168, 42.1, diabetes prediction 2.88, 33. Diabetes is more, please consult your doctor. And again, 139, 480, 40.7, 0.536, 21. So that's it, guys. So I hope you like the video. If there are anything to be mentioned, please mention in the comment. Your valuable feedback is